Hello, everyone, and welcome to today's third webinar of the 2022 Waste to Energy Research and Technology Asia Meeting, jointly presented by Global Waste to Energy Research and Technology Council, GWC, and Columbia Global Centers in Beijing. GWC, as you may know, is one of the foremost research organizations on waste to energy technologies, comprised of engineers, scientists, and managers from universities and industries in several countries. Up to today, our network is expanded to 20 countries around the world. And it is founded by the WtERT Engineering Center at Columbia. And Columbia Global Center is one of the 9 regional hubs of Columbia University, aiming to facilitate and promote meaningful academic exchange and research collaboration of Columbia faculty, students, and alumni with their counterpart in China and the East Asia region. I'm your host, Reda Kabash. I'm a research associate at the I'm host and presenter of this webinar, and I'm a research associate at the WtERT Engineering Center at Columbia and vice president in charge of the international relation at the GWC. Today's webinar will talk about the possible ways to build collaboration among academia, research institute, and government. And achieving the UN Sustainable Development Goals requires multilateralism and cooperation. There is no place for political tensions or division. We believe that China could be a vital ally to the American and European industry to support the expansion of the waste to energy technologies in Asia, Africa, and the Middle East. Renewable researchers and industry leaders from China, Europe, USA will present their best case studies, and also Japan will present their best case studies, experiences, and insight on international collaboration in the waste to energy. It is a great pleasure for me to introduce our speaker for today. So I will start with Professor Masaki Kawaka. He's a professor in the Department of Environmental Engineering. He's a graduate school from Graduate School of Engineering at Kyoto University. Professor Thanos Portsales is a lecturer at the WtERT and Environment Engineering at Columbia, and Professor Lynn de she's a technical and scientific officer at CEWEP, the Confederation of European Waste to Energy Plant. Xiaodong Yu, who is Vice President of International Division of GCL in Energy Technology, and Anh Zhao, who is the co-director and co-founder of Rock Environment in Engineering Institute, who will be the moderator of this debate. I thank you all, and also just to let you know that there is a recorded version of this webinar and will be available soon after. And we would love to hear from you. Just feel free to ask any question, and there will be all the speakers will reply to you at the end of this. After the speakers will present their presentation. So thank you, and I will give the floor to Professor Masaki Kawaka.
Yeah. Okay. Thank you. Thank you very much. So thank you. Thank you very much. Good morning and good afternoon, good evening, everyone. So my name is Masaki Takaoka. So today, I'm very honored to have a presentation in this webinar. Okay. So my topics is a temporal strategy of waste management toward carbon neutrality by 2015 in Japan. Okay. The content is here. So before the carbon neutrality, so I would like to briefly introduce current waste treatment in Japan. After that, so I would like to introduce that temporal strategy of that carbon neutrality in waste sector in Japan. And after that, so we set that some scenario and so estimation of the GHG emission and reduction. Okay. After that, so today's webinar topics is collaboration. So I would like to introduce the bilateral collaboration program, JCM scheme. And after that, so I would like to conclude my presentation. Okay. So this is a trend of 2025 in municipal solid waste in Japan. So incineration ratio is 80.5%, so very high, I think. On the other hand, so direct landfill percentage is very low, less than 1%. So recycling at 19 to 20%. So energy recovery of waste promoted from the viewpoint of the global warming prevention. So in spite of decreasing of the municipal solid waste, nowadays almost 41 million tons of waste is generated. The power generation is increasing. So the power generation amount almost 10,000 gigawatt hour per year in Japan. So I would like to move to the temporal strategy toward our carbon neutrality by 2050. So it is urgent need to take climate change measures. So in the fall 2020, late Prime Minister Yoshihide Suga pledged a cut in the greenhouse gas emission in Japan to net zero by 2050 in his policy speech. So original plan is 20% reduction by 2030 and 80% reduction by 2015. But he said, so target is changed. So 46% reduction by 2030 and net zero by 2050. So many ministry and so many ministry developed some policy. And so one example is the green growth strategy through the achieving the carbon neutrality in 2050. So, so we have to also reduce the GHG emission in waste sector. This is a current GHG emission in waste sector in Japan. So this estimation is based on the IPCC rule. So that category is landfilling, yeah, this one, and incineration. That's the biological treatment and incineration and use as fuel and wastewater treatment with blue colors and other. So as you can see, that incineration of waste and use as a fuel, use that waste as a fuel occupies about 90%. So we have to consider the two categories. So this is a detail of CO2 emission in waste incineration and their use as a fuel. So about 80% of the contribution, so that is waste plastics and waste oil. The graph indicates the trend of the waste plastics and waste oil. So in response to the waste plastic issue, including the plastic marine debris and export ban. So recently, the resource circulation policy for plastic in Japan has been implemented. So incineration of waste plastics and oil should be avoided, and the materials should be recycled as raw materials for chemicals. So we have discussed about that countermeasures to the net zero. So as you know that 3R, reduce, reuse, recycling is a very popular in this sector. So we add one word in this concept, so that's the renewable. So it means we need the switching from that fossil fuel-based material to that bio-based material or alternative. So it is difficult to express in 3 hours. In this direction, we set the key area in the waste plastics and waste oil and so also we need the GHG, more GHG reduction technology in waste treatment. So energy recovery from waste is more promoted, and carbon capture will be necessary to achieve net zero in this sector. So appropriate disposal of waste is also basic demand in this sector. So more energy saving and in this facility are necessary, and the collection vehicle of the engine will change that we do. In the operation, renewable energy should be used. So Ministry of Environment show that the basic concept of net zero in waste sector. So GHG emission will be reduced by the reduce and reuse and material recycles and feedstock recycling and switching to the biomaterials. However, some GHG emissions still remain. On the other hand, the GHG reduction by recycling is not estimated under the IPCC rule. So waste energy can reduce the GHG because the energy from the waste substitute energy or otherwise acquired from the fossil fuel in the thermal power plant. So because existing thermal plant will be still operated in 2030, so we can estimate that GHG reduction by waste to energy plant here. However, so please look at this one. So this is a renewable energy in power source in Japan. So at present, 20% of energy is originated from that renewable. And in 2030, 36 to 38% is estimated. And in 2050, so we should use that all energy from that renewable energy. So that means, so we cannot estimate GHG reduction by the waste to energy to achieve the net zero or negative emission. So CCUS will be necessary. This is one of case study, one of case. So this is a waste energy process CCU facility in Japan. So Saga City. So 300 ton per day stoker type and plus the 10 ton per day the CO2 recovery plant. And this plant so supply to that so heat and CO2 to the neighbor agriculture farm. So algae cultured and hydroponic cultured and vegetables. So if the CO2 is used in the agriculture site, because farmer would like to earn that heat and CO2, the incineration facility become a welcome facility and disappear the NIMBY program. So this is GHG reductions. So we set that 7 GHG reduction scenario based on that future waste generation. Anyway, so that is a BAU scenario, business as usual. And second, the planned scenario based on the existing goal and the strategy and the plan. And the 3, 4, 5, that's the extended plan and innovation scenario and extended innovation scenario, etc. So today, so I have not so enough time to explain the details. But anyway, so please look at this scenario 5. So extended innovation scenario. So still CO2 remains. So if we achieve that net zero, so we need that carbon capture. And this is the timeline of the introduction of the countermeasures. So one is a business as usual. We just considered the decline of the population. And so another scenario, so other scenario, so that is the same until the 2030. That means, so we just follow that existing plan, the GHG reduction based on the global warming prevention plan. After that, so we set various scenarios. Okay? And so 3, 4, 5 still remain that CO2 and net zero and so negative emission. Okay, so from here, so I will talk about the collaboration. So Japan proposed that the joint crediting mechanism, so JCM. So JCM, so facilitate that facilitate the diffusion of that low leading the decarbonization technologies, a product and system, and as well as implementation of the mitigation action, and contribute that sustainable development of the partner country. So that is a bilateral program to Japan and the partner country. And so finally we get reduce that GHG, and so we use that then to achieve that national decided contribution. So that program already started from 2013. So partner country is 70 countries, and 199 projects are already active or installed. And so among this project, so we have the 2 waste energy projects. So avoid that landfill gas emissions with the conversion of the municipal solid waste. So one type is a Yangon City waste energy plant, and another is Vietnam, Ban Ninh province waste energy project. Okay, so I would like to conclude my presentation. Waste energy is a promising option for preventing global warming in waste sector. The effective countermeasures for the waste plastic and waste oil are essential for the GHG reduction in waste sector. And the basic concept of net zero in waste sector was proposed, and the strategy for the carbon neutrality in this sector has been discussed in Japan. And we set that 7th scenario and so estimate GHG emission reduction. So even if the various countermeasures apply, the capture of 6.2 million tons of CO2 will be required to achieve net zero in 2050. So about the collaboration, so JCM scheme can be used for the diffusion of the waste energy. The future challenges are development of the advanced GHG reduction and technology and cost allocation, etc. We have many challenges, I think. Okay, thank you for your kind attention.
Well, thank you so much, Professor Masaki. Very interesting, and definitely, your university and Japan could play a very important role, to collaborate joint research with among our network, the compromise of universities, research institutes, and also film industry and developers of waste energy in China, in Asia, or in part in the world, Europe, in the US. And now I'm going to give the floor to Professor Thanos Portsalas. If the floor is yours.
Okay. Thank you very much, Reda. Can you hear me?
Yes, very good. Excellent.
Awesome. I will actually verbally explain our work with the United Nations in the last few years. was actually we were trying to understand the role of waste to energy within the circular economy and the low carbon economy policies. As we all know, at its purest form, the circular economy has no waste, leading to a perfect and optimal cycle that allows materials to be forever used once extracted from the environment. Currently, however, this is not possible for many, many reasons, ranging from the limitations of technology to basic human behavior and the social contracts that we do have. Therefore, until this perfect cycle is achieved in practice, society must and has the responsibility to employ all solutions available to sustainably manage materials that become waste. And when we talk about managing waste, obviously we do have recycling, composting, waste to energy via combustion, the most mature process, and worse come to worse is the use of land for the disposition of our materials. In this context, the waste to energy industry forms an interesting subplot of the transition to the circular economy. From this perspective, it is considered an industry with technology, but technologies that are transitory can go up as well as can go down. And the waste to energy industry can climb the waste hierarchy and become an industry with a future in the circular economy. Therefore, this will require the right enabling environment for the circular economy and waste to energy to go hand in hand. And our main conclusion from this work that we did with the United Nations, which in this document will be published in the next few weeks or so, it is very important that governments and all stakeholders, as well as new projects, adopt the 7 golden rules that we are actually proposing with the United Nations. The very first one is establish circular economy policy and government responsibility to keep an eye on all the different deployments, along with all the several pollutants that may be emitted from these operations. The second rule is that to internalize externalities, social acceptance, as well as investor mobilization, specifically for social acceptance. As we all know, waste to energy usually lacks this component when we're trying to deploy such systems in communities. Usually, waste to energy face public opposition, and public opposition directly affects the capital investment that is required for the deployment of such systems. To give you an example, in Dublin, the capital of Ireland, they tried to build a plant in 1996, and they had actually a huge public opposition for a good 20 years. The capital investment in 1996 was about $550 per annual ton. When they opened the plant in 2018, the capital investment was $1,700 per annual ton. So making sure that all the stakeholders are fully engaged plays a key role in the capital investment as well. The third rule is to provide economic incentives as well as price supports, because we're talking about technologies that are to be used for the transition to a more green environment. And usually, and if we assume that the baseline is the landfilling of the waste, which is actually a low-cost technology, a low-cost system, in that case, waste to energy along with recycling needs economic incentives as well as price supports in order to be viable. Set up comprehensive performance evaluation programs, provide some specific and strict frameworks in regards to the emissions, in regards to a roadmap that the specific cities, in regards to their priorities, want to see and what they want to achieve when the discussion goes to sustainable waste management and the circularity. The fifth rule is to select suitable technologies that are proven and mature and operate with sophisticated air pollution control systems. This is very, very important. And to give you an example, a few years ago in Thames Valley in England, they tried to build gasification plants. And we're talking about a developed nation. They had also citizens' participation, and the consortium was in an excellent position to provide high quality feedstock to this plant. However, after several years of trying to deploy a gasification plant, the consortium reported a loss of 900 million euros. So in order to avoid all this, especially when the discussion goes to developing or even emerging nations. It's very, very important to get an excellent understanding on the maturity of all these technologies. And when the discussion goes to the thermal treatment, combustion-based processes are the only proven and dominant in this specific field. Then establish transparent and open procurement processes and the adoption of a zero-tolerance approach to corruption in public procurement. This is very, very important. We have seen actually several projects, especially in the Southeastern Asian part, as well as in the Latin American part, where they failed because stakeholders were not really convinced on the intentions of some specific stakeholders. And the last but not least of all these 7 golden rules for the deployment of waste to energy to comply with the circular economy is to enhance local participation in projects that includes women's empowerment and vulnerable groups and ensure strong stakeholder engagement. The reason is that at the moment, according to the United Nations, we do have about 2% of the population in the global south that rely their income in informal activities. And when I'm saying informal activities, when the discussion goes to waste management, these guys rely heavily on informal recycling. So if we want to place or to build a waste to energy plant, maybe these people may lose their income. In order to avoid all this phenomena, it's actually ideally we must include all this population into the several stages of the deployment, which starts ideally from the design stage down to the operation and the maintenance stage. So I will be happy actually to answer any questions that you may have. Also, I plan to send the final document in the next few weeks with a group, but I'm here for you.
Okay, well, thank you so much, Danos. So, just to let to everyone that you've been involved to draft the report of the People First public-private partnership under the United Nations Economic Commission for Europe. I'm sure you're gonna the draft, as you mentioned, that it will be issued soon. I think within few months.
Yeah, okay, that's good. Now we're working on the final amendments. We plan to submit this to the Secretariat next week, and then they're going to translate this document in 3 languages during June. So hopefully in the beginning of July, we will have our final document.
Very good. Very good.
It's a document where actually we developed a framework for people first public and private partnerships for waste to energy projects in order to comply with the circular economy as well as with the SDGs. And for these public and private partnerships, we're not placing emphasis only on the value for money, but also on value for people.
Yes, thank you. Thank you so much. And thank you also for the case studies you mentioned, which is very important about the failure of this waste to energy plants. Unfortunately, in the world of the waste to energy, yes, there is a lot of sellers of miracle technology. So we need to be aware about that. And thank you for mentioning that.
Especially when we talk about for-profit organizations.
Yes, correct.
Sometimes they have the good intentions. Exactly. Yeah. Thank you, Reda.
Right. Thank you so much. Now I will give the floor to Jeff Xiandong. You. Please go ahead. You're in mute. Yeah.
Okay. Yeah. I'm very happy to join this webinar. And actually, I joined the webinar 1 and the webinar 2 and learned a lot. So let me share my screen slides. Yes. Okay. Yeah.
Meanwhile, I just want to invite more attendees to ask their questions, and we will very glad to answer them later on.
Okay. So you can see the full screen.
Very good.
Okay, yeah. And today's topic is for the 2021 WtERT Research and Technology Asia Meeting. And I think the topic is possible ways to build collaborations for the waste to energy in Asia. And actually, we in the past 2 webinars, we hear the voice from the academy and from universities and from industry. So I selected one point, just different. It's just from a developer to share why the experience, what we are promoting the waste to energy project overseas in Asia. I'm from the GCL Energy Technology. And I will brief introduction of our GCL group. Actually, our GCL group is pioneering of Chinese power enterprises, and the GCL group is the key business is for the PV solar power and the PV. We have the full chain of the PV industry, and we have the natural gas industry, and also the forerunner of the polysilicons. And my company is GCL Energy Technology. Our business is just developing the clean power project and domestic and overseas. We now have about 2,000 megawatts projects, and the waste to energy project actually is one of our portfolio, because we developing the wind power and the gas power, cogen power, biomass, and something else. And then now we are focusing on the waste to energy in the recent years. And this is our overseas sections. We have the 3 parts. One is the East European section, and the other one is in the South Asia. In South Asia, we focus on the Bangladesh and Sri Lanka. And now my team is focused in the ASEAN countries, like we talked in the Vietnam, Thailand, Malaysia, and these ASEAN countries, and Indonesia, to looking for the possibilities to develop waste to energy projects, including the wind power and PV solar power. But now today we talk about waste to energy project. Since 2016, actually our team already start to the very detailed the site investigations. I think the difference from our developers and with academic and from industry, and we think we are more close to the front, to the site and to the people's self. So I will share the experience we do in the ASEAN countries, now the experience in the Indonesia, what we did and we learned in the development of the project. And actually we can see that the Indonesia has about 267 million peoples, and they didn't have an incinerator project so far, and even a thermal gasification project in Surabaya, and only one. And before 2016, Indonesia have 3 let's say biogas projects, small mini biogas projects. One is in the Jakarta, the other one is in Surabaya, and the other one is in Bali. But all these tries in the biogas of this project failed because by the poor economic performance, and technically, I think the poor technicals on the collection of this gas. Now they switch to the incineration solutions. Besides the site investigations, we did very detailed investigations with different levels of the different organizations, and we meet the presidency, and we meet the ministry level, and meet the we call the off-taker. In Indonesia, the off-taker, we call it the PLN. So that's because they will buy our electricities. And also we spend a lot of time to talk with different cities because the mayors and the local, they call the body. So because there's like this waste to energy project were decided by the local officials. And in the middle one, we can see that we also communicate with the local peoples to see what's their concern for the waste to energy project. to solve our concerns and how to make our investigations in the past years one is just to solve some concern. How to make this project happen in a country just with this 260 million peoples, and how to make a project happen at like the 11 million. I think in Jakarta it's about 11 million people, and every day they have more than 8,000 tons of waste. But actually, so far, all the waste now it's just transport to this district is about 60 kilometers away called Bikasa to also. It's not a landfill. Actually, I visit there. It's open dumps there. Yeah. And what is the key obstacles prevent promotion in waste to energy project in these other countries? And these are the different levels was a concern. Is it possible to copy our experience to the Asia countries? The result is like this, because time limiting, and I introduced 6 key points we found in our investigation. The first one is the regulations and the legislations. And actually, all these other countries, before they can starting the search of the waste energies from the developer and investors sides, we are quite curious about the economic availables to see the legislations. What is the legislations? We need to have to see the clear pictures for tipping fees and the power tariff policies for the waste to energy project. And the second one is if we have the tipping fees, the policies, and the concession agreement. Sometimes in Jakarta, in Indonesia, they call it master agreement or cooperation agreement. This is very important for the developers to do the evaluations. The third one, I think this is this is very common for us because we are not manufacturers of the equipment. We are not technology suppliers, and we as a developer, we call it us with the IPPs, independent power producers. So this is a word that we call the power purchase agreement, PPA. This is not mentioned in other speeches, but actually this is very important for the developers, because we need to make sure how the produce the electricity will take or pay just take over by the power companies. This is very important for and the other 3 points is the local public consultation. I think this is mentioned in other speeches, and this is we call the LIMBY phenomena and the backyard problems. This is also, I think it happened in China, I think in the past 20 years, and now it's also happened in these ASEAN countries when they start to the projects. And the land issue, this is a very common and key issues in South issues. And the last one is the financing. All these 5 key points is very critical to support the financing. When I talk with the minister, when I will talk with the local officials, I always just sometimes is educate and let them know no financing, no project. Yeah. And now let me come to the point 1 is the legislation. Actually, in Indonesia, I think now it's they come to a new stage. So that's why we can see that the many projects has come to the tender stage in Jakarta, in Surabaya, in Bandung, and some places, because that the new regulations, we call the number 35 in 2008. In this regulation, and we now have the final, very clear regulations for the tipping fees, and have the workable mechanism after the concession agreement signed, and when and how we can sign I call it the power purchase agreement, PPA. This is the 2 key issues, and very specific equation to show how to calculate the power tariffs, and they have a very clear calculations there. I think this is the fundamental base for the Indonesia to the coming surge of the with the two energy projects. Yeah, this is happened in the 2008, and this is the whole pictures of the projects. Now we can see that they have the 12 big cities. They are coming to the stage in the tender stage and tender stage. Now that GCL and our Chinese company and now we are awarded to a project each, and GCL is responsible for the Jakarta East part, and the CNTY, one of the waste energy giants in China, they are now awarded the Jakarta South project. Now the project is in the progress under the financing stage and the pre-construction stage. This is called PPA. So I just explained that's why PPA is important, because in the PPAs for our development, PPAs need to be very specific to show that how we our electricity, what's tariff, what's offtake by the PAN, and in Indonesia they only have the traditional PPAs, because that before this with the energy, I think before the clean energy, they have the some many co-power, they have this traditional PPAs, but now the PPAs for the speaks waste energy, they don't have the draft. And now it's a process in the drafting, and we hope that the first PPAs for the Jakarta and will be the demo PPAs for the future, and for the future with the energy in Indonesia. And this is the last the question we call the public consultation. This is the actual pictures, and I think that we maybe saw some areas place and in other countries, but now it happened in Indonesia. Yeah, and there's no one that wants the project in the backyard, so it's happened there. And the right line is our future, our vision. We hope that they have this kind of project happen. So we are just cooperate with the experience in China, and now cooperate with the local government. And the first one is just educate and of the officials to how this waste energies benefits to the local people and to the local economy, and how this works, and to solve the problem. But I think the way is not so smooth, and with the time being, I think they can accept this concept, because in China now we have the 700 waste-to-energy projects already, and I think China also has the same problems, yes, as 20 years ago. But in the ASEAN countries, like in Indonesia, it's just the beginning. So it's a difficult way to do this, and but I hope that we will succeed for this one, with cooperation with the government and with local organizations. And this is the locations for the, as I mentioned, for the Indonesia, and that the two projects is under construction now, and this is the finance, because finance is quite important. As why we are so, I think it's anxious, and from industry side, from academic side, we have so many good technologies we want to transfer to the ASEAN countries. Why this not happens? I think it's the finance. The listed five key issues. I think it's obstacles, and we need to remove to make the financing happen, and then the project happen in these Asian countries. That's our researchers. And the last one is the page. This one is I just put it there. This picture is overview of the. I think everybody knows this is in the Bali, in the Basa. But we know the Basa is Bali is a beautiful place, and but actually the waste in Bali in the Suwon, we talked many years, but the project not happen. I think with the development and with the efforts from developer, we hope that this project happen and make Bali more beautiful. Yeah. Thank you. That's all.
Basically, there is also one important aspect you brought is about the consultancy with the public. It's very important to share, very transparent and share, to get them involved. That's very important, to move ahead with such a project. So now I'm gonna, invite Ms. Lee de Bruyker. I hope I pronounced it very well.
Yeah, so, it's fine.
Thank you. So the floor is yours. So you can start sharing your screen and make your presentation.
So there are a couple of topics the CWEP organization and European waste-to-energy sector focuses on. And first of all, this is reducing dependence on landfills, as it is well known that not all controlled landfill sites can significantly contribute to greenhouse gas emissions. So it is important to note that recycling and energy recovery in this instance go hand in hand to obtain this. Second, the support of quality recycling. So simply put, waste to energy keeps the recycling chains clean. And then also generating value from waste to energy bottom ash, which is reflected in recycling materials found in incinerator residues, which are bottom ashes or fly ashes and so on. And then these recycled materials can replace virgin materials. And then lastly, of course, it says so in the title, generating sustainable and reliable energy. And this again can be amplified by using even more energy from waste in the form of heat, such as like district heating networks. So to summarize the role of the waste to energy sector in sustainable waste management, firstly, it helps minimizing landfilling together with recycling. It secures energy and valuable raw materials that are produced from non-recyclable waste in an environmentally safe way, whilst providing society a service. And then it is also important to mention that waste to energy keeps other cycles in other sectors clean and can act as a pollution sink. So this slide shows an overview of all the waste-to-energy plants in Europe, again in 2019. I think there will be a few more in 2020 or 2022, this year. And in total, 99 million tons of waste was thermally treated in 2019. And here again, it's a graph showing the thermally treated residual waste throughout the years, including the number of European waste-to-energy plants. Also including Norway and UK and Switzerland. I have to be correct. But it might be more interesting, I think, to see this in comparison to other waste treatment options. And here throughout the years, you can see how recycling and waste to energy, the yellow and green line, go hand in hand for a qualitative improvement of both sectors and an increase in capacity. Landfilling, on the other hand, has gone down in the European Union. So the increase of recycling, composting and treatment of residual waste with energy recovery clearly indicates that waste is more and more perceived as a resource, which is a very important perspective. However, 24% of municipal waste across the EU is still landfills. And to view this on a more worldwide scale, there's almost 70% of waste openly dumped or landfilled. This is not very good news, but it also creates a lot of opportunities to handle this waste in a more sustainable and environmentally sound way. So I think this was a bit of a very general introduction on CWEP and the European waste energy sector. But another focus of CWEP is setting up studies and writing reports on specific topics the waste energy sector is dealing with. And I will present one such report that we recently published, because again, there's a lot of attention again to the emissions that, or the possible pollution that waste to energy incinerators can produce. So a recent report focuses on dioxins and waste to energy plants and provide a European-wide overview of all the analysis and the things the sector has done to avoid this. So dioxins and the waste to energy sector have long been associated with one another, mainly because of the sector's historical contribution, which was not insignificant. And CUEP prepared a report to showcase the sector's efforts and current commitment to minimize dioxin emissions. And it was based on extensive data from CUEP members around Europe. And this can provide an in-depth assessment of the sector's current monitoring practices of dioxins and furans. So this slide provides our main takeaways from the report. I will not go into detail on this now, but I will just talk about every conclusion in the next slide, to not lose too much time. So our first conclusion goes as follows. The European waste-to-energy sector is one of the most strictly regulated industries in terms of pollution prevention and control since 1989, specifically for dioxins, because then they got to know more about how polluting actually this compound is. And then today, the sector's dioxin emissions account for less than 0.2% of the total industrial dioxin emissions. And then the waste incineration BAT conclusions, which means best available techniques conclusions. They went even further and set more ambitious targets. And they also specified that monitoring must be carried out during other than normal operating conditions. So all the strictly regulations aside, it is very clear that this led to a great historical decline, as well as other sources of dioxin emissions becoming more prominent, which are mainly transport and households. I can also share with you a practical example. For example, the case of Sweden, they went from more than 100 grams of dioxins emitted per year in the mid-1980s to less than 1 gram per year in 2015, even though the sector's capacity more than doubled. I don't know the exact numbers, but it was more than double. So then the second conclusion, which mentions the extremely low dioxin emissions due to the sophisticated combustion control and pollution abatement system. It's very fancy words, but easily put, this just means that waste-to-energy plants have a highly controlled and complex flue gas cleaning system in place to avoid pollution through emissions. And so to illustrate this, you can see the dioxin measurements before and after one step of the cleaning system in the graph, which results in a 96% reduction approximately for one phase in the cleaning system. Then this conclusion also mentions that the low emissions are measured regardless of specific measuring equipment. This means that similar emission patterns between periodic measurements and continuous sampling are found, which means that the same results are obtained with either monitoring methods, so periodic measurement of dioxins sampling is done over short periods of time, 6 to 8 hours, and then continuous sampling is carried out over longer periods of time, which can vary from 2 to 4 weeks. And then the last conclusion of the report reads that there is no correlation between dioxins measured in the environment and emissions at the stack, regardless of the sampling methods. The sampling part we have already covered in the previous slide, but it is quite interesting to know, in my opinion, that whilst environmental samples provide a value of the amount of dioxins measured in that sample or in that biomarker, it does not necessarily determine the emission source. So, but more on that later. And then also the report includes different examples of biomonitoring of dioxins executed by waste-to-energy plants. If you want to go into detail, the report is freely available. But I think it's very important that we come back to the challenging task of identifying the emission source. So it must be noted that it is not really possible to guarantee the source of dioxin emissions solely based on the levels in biomarkers. So the biomarkers are samples you take in the environment around the incinerator plant. And then plus the pollutant concentrations found in that sample can originate from both recent sources in the environment or from far away, and as well historical pollution due to the bioaccumulative nature of dioxins, which are also labeled persistent organic pollutants. So for some processes, it is possible, however, to identify the source based on congener patterns. So congeners you can kind of see as chemical compounds, or simply put, building blocks, and they are related to each other, and they can give more information on their origin. But as dioxins are a group of over more than 200 compounds, you can set up a congener pattern for a sample, but also for an emission measurement. And if both patterns align and these match, you know the source. However, this only works for emissions from a certain industrial process if this process has a very specific congener pattern, for example, for pulp bleaching. For incineration of municipal waste, however, there is no conclusive congener pattern, because for most combustion processes, the congener patterns that are found are very similar, regardless of the input, whether you burn waste or you burn something else. So combustion processes, they have very similar congener patterns. So the only way to find the actual source is to compare with a framework of measurements from all potential sources in the surrounding, including stack measurements. And then this is just my last slide as a very quick overview of the different monitoring methods, starting with the direct link. And the only link you can be certain of is measuring at the stack, like the flue gas at the chimney. This is the only direct link of knowing what your emission source is and what you actually emit from your plant. All the other ones are biomonitoring and air quality monitoring, which are also very valid to know whether there is a polluting source in your environment, but it does not necessarily directly lead back to the waste-to-energy plant. And I think that is it for me. Many thanks for your attention. And if there are any questions or anything, I will be happy to answer them.
Well, thank you so much, Lynn, for your presentation. Very, very great. And thank you for sharing your finding about the research about dioxin and waste-to-energy plants in Europe. I'm sure, as you know, that we were already worked all together with the WtERT GWC, and now since we created, our cluster in WtERT Asia, hosted at the Columbia Global Center, it will be an opportunity to collaborate, both with the local industry in Asia and universities to do more cooperation in the joint research project in dioxin. That would be very, very interesting.
Mm-hmm. Okay.
Basically, I'm gonna start sharing. By the way, thank you so much for all the attendees that they provide some questions that with the moderator later will share this with you, all the speakers. But before that, I will just very quick, sharing my. I would love to make a presentation about the WtERT. Okay, there you go. So just for everyone, so gonna start, presenting, our research center, the WtERT, Asia. So basically, the Waste-to-Energy Research and Technology Council was founded in 2022 by the WtERT Engineering Center of Columbia University in New York, and the Energy Recovery Council, which is one of the U.S. Association of the Waste-to-Energy Companies in the U.S. So the EEC is the engineering unit of Columbia University's WtERT Institute, and its mission is to develop technologies for sustainable development goals, and more focuses on the earth resources, minerals, energy, water, and the environment. Over the years, universities and our organization in several other countries, created WtERT organization. And it was result in 2011. It was, we created a non-for-profit organization, which is the name of Global WTE Council, that is now englobe several partners from 20 countries up to now, from all the 5 continents. And that's the vision, and the mission is to bring together engineers, scientists, and managers from the universities and industries to work all together to develop a solution to major environmental problems. And one point that I want to share, that there is an African proverb that says that if you want to go fast, go alone. But if you want to go far, go together. So basically, the mission of GWC is to identify the best available technologies for the recovery of materials and energy, more specifically for the urban and for the municipal solid waste and other residues from human activities. Conduct research and development, and also this is the most important, it disseminate this information and inform the public, industries, governments by means of publication, web, and this sort of meetings, such as this conference. So basically, the objective of GWC members organization are to increase resource recovery from used product and minimize the environmental impact of the waste disposal worldwide. So one of the guiding principles for our organization is that sustainable management of waste should be based on the science and best available technologies, and not what seems to be inexpensive today and could be, unfortunately, be very costly in the near future. As you can see from this, the world map that we are present in several countries around the world, up to now 20 nations from different parts of the world, and our vision is to support Africa and also Southeast Asia to reduce the gap between Europe, and also China, to help these countries, accelerate the development of waste energy technologies, and also, support them, to implement, the waste energy technology. So our members, Professor Temalesi is the founder and the president of the Global WTE Council. Werner's our vice president responsible of the technology, as one of our speakers, Professor Tanner Broussard, who is the VP in charge of the global development. Dr. Hanwei, he's in charge of the engineering. Professor Huang for the academia, and myself as the international relations. Some major achievements of the GWC is we create a website that englobe a lot of information, theses that you can share, check it and see a lot of information that's very useful. And also, Columbia University conduct U.S. survey of waste management. That the findings have been regarding the result of this study have been used by the EPA, the Environmental Protection Agency, in computing the greenhouse effects of managing municipal solid waste in the U.S. Also, there is some international recognition. GWC has been recognized by the most prestigious award of the Materials and Energy Division of the American Society of Mechanical Engineers, and also by the Confederation of European Waste to Energy Plant, that ILIN is part of it. GWC also co-authored the Waste Management section of the 2015 Assessment Report of the Intergovernmental Panel for Climate Change, and also was one member of the Technical Advisory Panel of Singapore Environmental Protection Agency for the development of environmental guidelines for the beneficial utilization of waste to energy bottom ash. Also, there is an engine that englobe most comprehensive online database under the auspice of the GWC and the WtERT Engineering Center that you can check it online. And also, one of the major contribution is on the GWC release report, the guideline of the waste management that guides Latin Americans and Caribbean cities on how to proceed with selecting the best waste management technologies and executing multi-million projects. This guidebook is available on Google for free, and even in our website, gwccouncil.org, and it's translated in several language: Portuguese, Spanish, Greek, and its Chinese edition also is underway. So basically to share it to the Chinese. So also there is some pre-feasibility studies that have been conducted for several cities in different countries, and also we support government also to advance and promote the waste to energy technologies, like for this example in Turkey with the visit of the First Lady of Turkey to Colombia. And hopefully, the Turkey built this first waste, one of the largest waste to energy plant in Istanbul. So basically, we're so proud that countries are moving toward waste to energy to phase out the landfills and generate energy instead of landfilling resources. With Colombia Global Centers, GWC has participated in several regional hubs in Mumbai, Santiago, and Rio. Thanks to Professor Thanos Brutals, who is very active, promoting waste to energy toward Colombia Global Center. And we are very, very so excited. And thank you so much for the Colombia Global Center Beijing that hosts WtERT Asia as our cluster in their premises. And we're looking forward to do a lot of activities, seminars, and bring together academia, industries, and also entrepreneurs, students, everyone all together to promote waste to energy, share information, and collaborate all together. One of the very important things that we need to act very fast, that as you can see from the project to waste by region, the waste is going up. So therefore, we need to act now to phase out the landfills, because those waste that are going to be generated, within up to 2050, they need to be treated. So waste energy should be promoted, and they start to be built now. So thank you so much, and I will let the floor to. So I will let the floor to our moderator, Hangs up, so to lead the debate and also to answer all the questions from the attendees. Thank you so much.
Thank you, Reda, and thank you again for inviting me to join this session. And our panelists have provided very informative and quite enriching experience and research lessons. So from my understanding, I think the waste to energy has a variety of the challenges and opportunities under the very complex world and context relating to the economic uncertainty and also related to the public health and the environmental issues. And the third one is about the climate change. Professor Takoka had lots of information and recommendation about how waste management and the waste sector can contribute to the net zero scenario in Japan for the next 30 years. The fourth one is about the regulatory challenges. As Jeff mentioned, Chinese companies, GCL has investments in a member of the ASEAN, Indonesia, and has to cope with the local regulation challenges. And I want to firstly ask a question which might have to do with every panelist. And then I will give our participants of this webinar because they put some question there. And I think many of them are very relevant and very interesting to discuss. So my question is about the affordability, if you like. We have the cases in Japan, EU, and China, but it's not directly, but GCL is a major investor in the Indonesia in the waste to energy. So we're focusing on the international collaboration about the waste to energy. So I think the first thing that we have to answer is about how can we apply the lessons and expertise from some countries which have been working in this area for a long time, like Japan, the EU countries, into some countries who are still in the low income levels. And we know in the EU, the most strict regulation, requirements on the environmental impact of the waste to energy project, it's hard to think about how in those countries like Indonesia to comply or to follow the same levels. So my question is that how can you give the idea the affordability of the waste to energy project if we want to introduce the technology investment from like developed countries like Japan, EU, even US, but we don't have the case sharing from the US colleagues. And also the second biggest economy, China, is playing a big role in this area under the Belt Road Initiative and also other strategies. So if our panelists can share their comments. So do you think from our Professor Takota, do you think Japanese experience about the economic analysis of the waste to energy can make difference in those countries they really want to cope with their waste problems and also the like the Indonesia and others. So we start from Professor Takota and then Jeff and Ms. Lin and also Thanos. I think we can first in this first round we can get some our experts' comments on this issue.
Okay, thank you very much. So that's a difficult question, I think. Yeah. So in Japanese case, so municipality is responsible for the management of the waste. So that Japanese waste energy plant also supported by that in the tax. Yeah. So I think that a little bit expensive compared to that other system, I think. Yeah, but so anyway, in the developing countries, so today I introduced the one scheme, JCM. So Japanese government or Japanese funding agency or others or so supply that some money to construct that initial investment. And so after that, so operation maybe could be by the developing countries, or of course supported by that so developed countries and etc. I think, yeah. So that's funding scheme is I think that effective to spread that waste to energy system in developing countries. I think. Yeah. Okay. Thank you.
Okay. Thank you, Professor Takota. I just one small add-on. You mentioned about to achieve the net zero of the waste management sector in Japan, you have to avoid the burning the waste plastic and the waste oil. That is the key from your presentation. Do you think how far the Japanese government and the whole economy has done in this field? Do you think it's really workable in other countries to cope with this? Because the plastic pollution, the plastic issue is really one of the key challenges.
Yeah, I think so. Yeah. So in Japan, so now at present, so we incinerate it. Yeah. But in the future, so if we achieve that net zero, so we have to avoid that incineration of the plastic. That means so we have to recycle them more and more. So especially so we have to make that closed loop of the plastic recycling. So that means so gasification of plastics and make that so chemicals, some raw materials, and the chemical industry also use that so to make the plastics. That's an ideal case. That I think that it is difficult, but now so Japanese industry also challenge to make that closed loop. Yeah. just developing. Yeah. Now we installate it and we change to that energy. Yeah.
Okay, thank you very much.
Yeah.
So let's listen to Jeff. Jeff, you mentioned a lot about the financing. I mean, we hope your investment in Indonesia can really make difference, particularly for those countries like very populous and many big population. The waste generation is a huge issue in the urban areas. Can you share with us? In those cases, do you think how could you solve that financing issue? I mean, that's the key issue. If it's not profitable or it's not sustainable in cost and effectiveness, how can you scale up the investment in more countries?
Yeah, thank you. I think that this is a very good question, and this is it's what we concern from our IPP as a developer side. Actually, as I discussed in the PPTs before 2018, actually the waste energy project really delayed is these developing countries in the Southeast Asia and is South Asia delayed. That's why we say is one for a question is that China has the 700 waste energy projects. Why we cannot copy this to these developing countries? The problem is the economy. Now, I think from our side, I think the situation is changing. Actually, is this. Actually, the first one is a capex. With the development of Chinese projects and Chinese manufacturers and the EPC companies have joined to these developing countries in the Belt and the Road initiatives. These EPC countries and companies and the manufacturers have greatly reduced the equipment cost and the EPC cost. This, I think, is one reason to make the economic major for the projects in these countries. And the other one, as I mentioned, that for the IPPs, that we need to prepare acceptable EIR. So that's for our IPP development. So the two key factors, one is the power tariff. Okay. The second one is the tipping fees. Now these different countries, they now have starting to have the regulations for these two key parameters. Actually, it's now began to make this project economically available and with reducing the EPC costing, and so that we can see that the 12 projects starting to the tender. Jakarta, Bandung, Surabaya, and Makassar, all these cities. And the third one, I think, with the supporting bank, I ask of what the many banks that now is supporting the clean energy increases with the energy projects, so we are connecting these banks and lenders with some good terms to finally combine these issues, the power tariff, tipping fees, and the supporting from banks. We can make these projects in these developing countries happen. This is the right time now.
Okay, thank you, Jeff. Let's move to Lin. And you give us a very good case study and also reports about the toxin control in the EU. My question is also related to the affordability of the waste to energy in the EU members. EU members have different economic development levels, but EU has very strong control of the pollution or pollutant from the waste to energy standards. So if you can give us some information between the Western EU members and the Eastern EU members, how the EU regulate the waste to energy project in these two parts of the EU? Do they have the similar environmental regulation standards, or do they have different, or maybe they give more subsidies to the Eastern member countries to increase their technology and management level to control and minimize the pollutant emission from the waste to energy? Can you share some information about that with us? Thank you.
Yeah, of course. So as you mentioned, the European Union has very, very stringent environmental regulations for the waste to energy sector. So for the polluting factors and for example, emission levels, they're set in stone. Countries can choose to go further, even further. Some countries do. And as you mentioned as well, there is a huge difference among member states. Well, members are more focusing on implementing carbon capture usage or storage technologies. Other members are more focusing on energy efficiency. So it differs very much between our member states as well. If there is a particular East-West division, I wouldn't say. It's maybe a bit more North-South. Because the perception of waste to energy is also very different. So in the North, they're really, really focusing a lot on carbon capture and getting to decarbonization and carbon net zero. So there is a very strong focus there. And in the South, there's more focus on energy production. And not everyone is in favor also there for waste incineration itself. But for legislation-wise, it's a European legislation. And then for some things, it differs between member states, between all member states. I don't know all of them by heart. I'm sorry for the legislation.
Okay. Thank you, Lee. It's very helpful. And let's move to Thanos. You share a lot of research experience. So my question regarding this is about, the climate policy has been led to a large extent in the past few years. EU has made the big milestone to speed up the climate actions, and then US join, and China and Japan and South Korea join. So as far as I know, EU has a very big ambition about the circular economy. You also mentioned, and we know the circular economy has a big tension with waste to energy industry. That's my understanding. So how do you provide your observation? On the one hand, you want to pursue the circular economy to really solve the model of the economic growth and to really reduce our dependence on the natural resources. On the other hand, EU is a big industry of the waste to energy around the world. Technology know-how and also the investment can go to other countries to share how to use their technology to solve the problem about the waste. So this is a kind of very tension between these two things. Can you share your idea about that?
Absolutely. It's an excellent question, and thank you very much for bringing this up. I mean, we must understand that we're talking about materials and waste management. And when the discussion goes to waste management, we do have materials that simply cannot be recycled. For example, we mentioned, earlier about plastics. I mean, we know that we have 7 broad categories of plastics, whereas according to the American Chemistry Council, we do have over 10,000 different types of materials. And most of these materials cannot be recycled. They don't have a value in the market, and they have actually high contamination rate. It's like, for example, diapers. It's a material that simply cannot be recycled. So for this specific fraction, instead of using landfills, instead of using land for the deposition of all those materials, it's better to recover the embedded energy that these materials have. According to also to a study that was published by CEVEP a few months ago, even if the European Union by 2035 achieves all these ambitious recycling goals and targets by 2035, even so, we will have to deal with another 30%, Lynn, correct me if I'm wrong, 30% of the residual fraction, the non-recyclable fraction, which again doesn't have a value in the market. So in order to avoid any misunderstanding, and as also Lynn very well said, recycling, composting, and waste to energy go hand in hand in all the successful paradigms and examples that we have seen around the world in our effort to divert materials from landfills. As you mentioned also in the very beginning of your question, last November, President Biden, along with the European Commission, signed the Methane Pledge and initiated a global effort to reduce a potent greenhouse gas, which is methane. Landfills is actually the second anthropogenic source of methane, followed by the agricultural activities. And that is why if we really want to do something to reduce methane as well as greenhouse gases and achieve all these ambitious, close to zero carbon societies, we must actually design solutions to divert materials from landfills. And we must understand that waste to energy competes only with the landfilling of the materials, not with recycling or composting. To give you some examples like Austria, Switzerland, Germany, Korea, Singapore, all these examples that I mentioned, the Netherlands, have actually designed systems upon recycling, composting, and waste to energy. And as I mentioned also in the very beginning of my talk, I mean, until we have all these new technologies, until we have all these new materials and products, and in regards also to the growing population and urbanization that we're experiencing at the moment, we must provide environmentally benign solutions for waste management.
Thank you, Thanos. Thank you very much. And we also have Professor Nicholas Themelis here, and we're happy to have here. And I think we may give some time for our Professor Themelis to also share the idea and also surrounding our discussion. That would be great. Okay.
Thank you. Thank you very much. This has been an excellent presentation. I'm very impressed, and thanks to the organizers for putting so many people from different parts of the world to discuss this. I noticed, for example, that the list of the list of Jeff Yu of things that have to be done to accomplish waste to energy is very similar to the list that Thanos put forth. Now, tonight we have or at least tonight here for New York, for US, we have the last segment, and I'm supposed to make a presentation there. And I've learned a lot from yesterday's presentations and from today's, so I can form my presentation. But I can say this, that waste to energy, to my mind, is in the same category as wastewater treatment, the same category as provision of water, the same category as provision of electricity. In other words, it cannot be left to individuals or even to municipalities, although some municipalities, for instance, in Japan, they are conscious enough that they put their money to build plants. That's what has worked. But if it doesn't work at the individual level, at the municipality level, it has to work at the national level. The same way, like you have to provide for wastewater treatment, not to let it pollute the rivers, which in some cases we still do. The same thing has to apply to solid waste. And regarding another question was brought up earlier between South Europe, I come from Greece originally, and I'm very disappointed, despite all our efforts in Greece, that there has not been a single waste to energy plant, although they belong to the European Union. How they do it? They pay fines. They pay hundreds of millions of dollars of fines to the European Union because they don't want to. They have not so far. But right now, Greece planning to put 4 waste to energy plants. So let's hope for the best. Thank you very much for your presentations, and see you, some of you, this evening.
Thank you, Professor Themelis. The last story about great situation is quite interesting. We know even within EU, there are some special cases because some countries, from the people's preferences, they may say no, or maybe they don't want to have some. But as you mentioned, there are some new developments and updates from Greece. We hope, because waste to energy is one of the solutions, one of the ways to cope with the waste management. So as I see the questions raised by our participants, there are two questions, but they're quite relevant with the tension or the issues between EU circular economy and also the waste management, particularly focused on the incineration. I think what we see from the cases from China's investment, companies' investment in ASEAN country, and from the EU environmental regulation of the waste to energy project, and particularly from the Japan's strategy about how the waste sector can really contribute to the national net zero strategy. I think it's really complicated issue when we combine the waste management itself, but also the climate change and the regulation and also environment. So I think by the end of this webinar, for me, I learned a lot, but I think there are a lot of questions regarding the country's context, because, as I mentioned, the fourth pillar about the waste to energy collaboration is about the regulatory system or regulatory framework. Every country, China is a big leader in the waste to energy industry, as Jeff mentioned. Hundreds of the waste to energy project has been built up, and in the next 5 years, even more will be built. But why in the Asian countries and other developing countries, the development of the waste to energy still have many challenges? I think at least one of the big issues about the regulatory framework. So I think we have almost, we already go beyond our time, and we're supposed to have a 90 minutes session. So I thank you again for our panelists and also our participants from all over the world. I would like to give the floor back to Teda, and I think if you have more concern or question about this issue, we may have in the future have opportunity to discuss again. I thanks again for all organizers.